Okay, welcome everyone. Thank you so much for coming. I see there are still a few people walking in, so I'll just give it a minute. And then we can begin. If you're looking for Duncan, I think he's in a different room, slightly less hair. So if you're looking to talk about Kubernetes, you're in the right room. So thank you for coming here and, to my session. My name is Katarina Brookfield. I'm part of the technical marketing team in the VCF division. And Kubernetes and our cloud services is kind of my story that I like to tell. So what we'll be doing in this session, we do have 45 minutes, and this is a very big topic, but hopefully what I want to do is show you what we have done, especially in VCF 9, what is the private cloud that we have delivered, especially when we're talking about these modern aspects of it. And when I'm talking about the private cloud story, it's really important to kind of start to establish what exactly do we mean by we have built a private cloud? Well, the most important thing is that we really wanted to build that cloud experience on your premises. So give you that access as consumers would have to like loads of services you can use for your applications, but also with the governance and policies that the admins still have in place because you are doing this on premises. So that security part is a very big part of that story. But in here, to show you what we have delivered in VCF 9, I really want to start with looking at why are we doing this? And, well, the answer to that is very simple. If my thing moves. If this moves. OK, just give me 1 second. Sorry about that. Let me change that. This may be easier. Right. It's all about the apps, right? Because it's no longer about deploying a virtual machine or a container on a platform. Apps, and especially modern apps, they need way more than just a place to run. You need access to things like load balancers, to things like persistent storage. You need access to container registries, for example, but also to logging and monitoring and all of the other things that you would need to make your applications really work together. And what I want to showcase is how you can use the cloud services that we have delivered in VCF to build an application end-to-end. And to do that, we will demonstrate this on building an application. And it's going to be a very simple application that has 3 tiers. And the point of this demo isn't to show a super cool app, but more to show the relationships of the components and how we can use the services to deliver this. So our 3-tier application will have a database tier. It will have a backend API that will be connecting to the database, and then also facilitating connection to frontend, which will just give us a web user access. When it comes to the database, we'll use a VM service to deploy a MySQL database. Not just deploy it, but fully configure it, create the tables, and everything that we need. Then, in order to be able to connect to the database securely, we're going to take the database credentials, and we're going to store them in a secret in our secret store. This is one of the new services we have introduced in VCF 9. We'll then later on go ahead and deploy a Kubernetes cluster with our vSphere Kubernetes service. We will deploy the backend, part of the application, which is running in a container, with the injected secret from the secret store. And later, we will show how we deploy a front end of the application to get this web UI and connect there. But if you've ever been to any of my sessions, I do not really like to do many slides, so we'll just jump into the demos and we'll just go through the actual experience. And this is it. So where I'm starting is our VMware Cloud Foundation portal. In VCF 9, we have really restructured the way we work with our portals and our access points. And in here, I'm logged in as a consumer who has been given access to a certain space, a certain project, certain namespace where I can deploy my applications. So as soon as I get a URL, I can log in. And in here, I see what I have access to, some utilization data I want to see, also a list of services that I can use. So I'm going to go ahead and start with that virtual machine deployment. And this is really simple. I'm going to go deploy a new virtual machine from an OVF template as a base. I could do ISO as well if I wanted to. I'm going to give the virtual machine a name. And then I can also select a zone where I want to deploy this. Next, I'm selecting the VM image. Now, the VM image is something just a standard VM template. But this is something, the list that has been curated by the cloud admins. All they have to do is either create their own images, or, for example, what I'm using here is just a standard cloud image that you can get for Ubuntu, for example. So just download that, upload that to a content library, and that gets exposed for me to use. Next, I'm configuring something we call a VM class. And if you have experience working with public clouds, this is a very common way of configuring hardware resources for virtual machines. So it's this kind of T-shirt sizing for VMs. So I'm configuring things like CPU and memory, but it also has all of the other options. So for example, if you have any additional PCI devices, it could be included in VM class, any advanced options you would have on VMs, and so on. So for the purposes of this demo, I just need 2 CPUs, 4 gigs of memory, and then I can continue. When it comes to the advanced settings, this is where it's starting to get really interesting, because here we can start seeing how we integrate all of the services together. So for example, if I needed extra persistent storage, I could directly in this flow request a persistent volume. But what I will do as well is create a load balancer on demand. So I need to expose my MySQL application on certain ports. So what I'm going to do here is I'm just going to create 2. One will be for SSH on port 22, so I can log into it if I need to, and then MySQL with 3306. So all I'm doing as a user, I'm defining my desired state, what I want, and the platform will go ahead and do this for me. And this last section is really the very powerful way of not just deploying virtual machines, but fully configuring them, because I can pass my guest customization to the VM to fully configure it. Now, because I'm doing Ubuntu, I'm going to be using Cloud Init, but if you would be deploying Windows, you can also use sysprep. And to make this even easier for maybe those of you who may not be familiar with these tools, we have provided guided inputs directly in the user interface, where you can go and configure some of the basic configuration things. Like, for example, if you want to create a new user, you can directly define it in the UI. And you can also just use your run commands to run any commands that you want to do on the VM to configure it. Now, Cloud Init will run during the first boot of the VM to bootstrap it. So it will run through the full configuration. So you can use the guided inputs, or if you do have a cloud config already prepared, you can use raw configuration, which is what we will be doing in this case, because it's a bit more complex what we want to do here. So just to show you what I'm doing here is I'm creating a user, I'm creating a group for it, but then I'm also creating my MySQL tables, in the database, the tables, and then configuring it, installing it, starting the service. So everything that I need to get my database up and running. I will add this. And next, we come to network configuration. For this demo, I don't need to change anything, but what I want to highlight here, another thing we have introduced in VCF 9 is the ability to fully self-service networks thanks to our integration with VPC. So if I wanted to put this on a different network, I could go ahead and create it myself and then use it for my deployment. For now, I'm just going to use the default. And then I could go ahead and deploy this virtual machine. Now, what is really interesting is that every single resource I have requested in this flow has been captured in my YAML manifest on the right-hand side automatically for me. So I'm able to download this and reuse them later if I want to use it for other purposes, or just redeploy this, and we may see that later in the demos. But what's really cool here is that because everything we are deploying here is captured in a desired state, I do not have to know how to write these resource manifests myself. The platform does it nicely for me. So I can go ahead and download those, and then go ahead and just deploy this virtual machine. And after a while, we will see that MySQL VM will be powered on and configured. We can now move on to the secret. So as I said, I want to be able to connect to my database securely, and I want to store those connection details somewhere. And we have introduced a new service called Secret Store to deliver this. This is based on OpenBOW project, so we will see how we can work with that. In my command line, I'm going to create the definition of a secret. I could do this in the user interface, but I do want to show you the versatility of our platform. If you're familiar with CLI and prefer to do that, you can always do that, or you can use user interface if you find it easier. So in here, I have a definition of my secret that has my connection details, my DB user, my DB password, and my DB name. And then I can go ahead and just create this. And to do this, I'm using our brand new VCF CLI that we have introduced in VCF 9. If you have worked in this area before and worked with our products, you may be familiar that we had multiple CLIs to connect to the environment and maybe do some of these operations. We have now unified the CLI completely. It's also plugin-based, which gives us really the ability to introduce new functionality into this really quickly. So for example, the secret part is a plugin. So we can teach the CLI how to work with certain objects. And all of these plugins are then automatically synced. When you log in, it will go ahead and grab what you need. So I've used that to create my secret. And now if I list it, I will see that the dbcrat secret is in there. So that was the second part of the application. And now we come to the Kubernetes part. We will be deploying a Kubernetes cluster with VKS. And before I start the demo, I just want to quickly recap where we are with VKS. vSphere Kubernetes Service is something that we have been working on for some time now, and I can very proudly say that now we are at a very good point with it. It allows you to deploy fully conformant Kubernetes clusters on demand. These clusters are extremely scalable. You can size them correctly to your needs. You can very easily integrate it with the rest of the platform. So if you need to provide it access to resources like GPUs, very simply through that implementation of VM class. And everything, as you will see here, is on demand and easy to do in the user interface, but always keeping in mind that you can always do advanced options directly with the API. We use Cluster API project to bootstrap our clusters, which you will see once we start deploying it. When you start deploying clusters in the user interface, you do have two options. The default configuration will just grab the latest version available, and a minimal configuration of a single control plane and a single worker node that you can literally deploy in 2 clicks. For the purposes of this demo, I'll show you what's in the custom configuration. So in here, I'm going to give my cluster a name, and then I go to select the version. So as you see, as a consumer who is deploying this, I see versions of Kubernetes that are available to me. These are called vSphere Kubernetes releases. And the way we distribute this is using a subscribed content library that gets created automatically when you enable the platform. What's also important to mention here is that if you are in a role of the infrastructure admin or a cloud admin, you are in control of the service itself and also able to update the service versions. Why this is important? Well, because we have completely decoupled the delivery of new versions of Kubernetes from the rest of the platform. This was a very important step because in the world of Kubernetes, we cannot wait 6 months or more for a new version to arrive. So what we can do now is we can, every time there's a new upstream version of Kubernetes, we try to catch up really, really quickly. Recently, we've been very successful doing that, and that's the goal moving forward as well. And so after the upstream Kubernetes is released, we will release our version. And then in order to unlock the version, the admins just need to update the service. It's a very simple process. If we will have some time at the end, I can show you. It's literally just a few clicks for the admin to do. But with this, we are able to get the latest and greatest Kubernetes flavors. So for example, what you see here, when we GA'd VCF 9, it included version of VKS service 3.3, which included version of Kubernetes 1.32. But at the same time of GA, we also released the independent update for the service, version 3.4, that gave us access to 1.33. So we are fully aligned with upstream Kubernetes in our offerings. So once I select the version, I'll go with the latest. I can do some other configuration options directly in the UI if I want to add some labels. For example, if I want to do certificate rotation, one of a very common topics we need to be talking about and configuring, so I can do it directly in the UI, and some other configuration options as well. But for now, I'm just going to move on to the other section. So first, I'm going to define my control plane for this Kubernetes cluster. I'm going to define one replica count for my control plane, the VM class, again, to give it resources that it needs. Then I'm selecting a storage class, which is basically a storage policy that points to a particular data store where the files will be located. And then it comes to the OS image. When it comes to control plane nodes, you can deploy either we distribute Photon or Ubuntu. One new thing, again, we introduced with the latest version of the service, 3.4, was our long-term support for the releases as well with Ubuntu 1.33. So now you can get, if you do have the need to stay on a particular version a little longer because of your application needs, we can do that, and we can support you on that as well. And next, I'm going to configure my worker node pools. So again, here I'm defining how many do I want, what sizing do I want, which OS image I want. When it comes to the workers, for the purposes of this demo, we are deploying Linux-based, but if you do have Windows containers, we do support Windows as well. So we give you a process that you can follow to create your own Windows-based images for your Kubernetes clusters. Also in the UI, I can, one of the new things now, I can add any labels or taints, for example, if I want to. And if I wanted to, I could also directly here request additional persistent volumes, again, if I want to give it more space. For example, if you are deploying clusters that use GPUs for your AI/ML workloads, you usually want to give it more space for the NVIDIA operator, for example. So it's very powerful. Also, when it comes to the makeup of VKS clusters, as I said, they're extremely scalable, but also the idea is that you can create clusters you need. So if you wanted to create additional node pools with different configuration, different OSs, or different sizing, you could do that as well. So you define the whole cluster in here. And at the end, again, the full cluster YAML spec has been created for me. So I can go ahead and download this. And again, same reasons as before. Maybe I want to reuse it. Maybe I want to use it for something else. One of the other reasons why I often do it is, again, keeping in mind that what you see in the user interface is just a subset of what Cluster API can do. So if you want to do any advanced settings that may not be fronted in the user interface, you always have access directly to use the API and add those configuration steps as well. So now we'll just go ahead and wait for our cluster to be deployed, which will just take some minutes. Now, I want to show you what's actually happening on the background, because sometimes we do these demos, we just focus on the consumer side from the cloud experience in that portal, but I do want to link that back to the vSphere world that we are familiar with. So if we look in our inventory, we will see that there's something called a namespace. So this is a vSphere namespace. It's basically this logical unit that has been carved out to give me access where I can deploy my resources. But we also use it for things like setting resource quotas or limits, also to do some further configuration on things like which images we have access to through content libraries, associations, and some other basic configuration, like, for example, which VM classes are allowed to be deployed in this space. So again, giving the admins the full control over what gets deployed in here, so the consumers can just go ahead and do whatever they want within those defined guardrails. So in here, I can see I have my MySQL VM, and I can also see my cluster is being deployed. So this always starts with deploying the control plane first, and then it will go ahead and deploy the worker node as well. If you would be deploying multiple control plane nodes, you will notice that it does the first one, then it does the worker nodes, then it finishes the other two. The reason for that is that obviously we need the first one to provide that API to connect to the cluster and do the rest of the configuration if you have ever built a Kubernetes cluster as well. Right, so now that we have our cluster deployed, we can connect to it. And what I want to show again here is how we can use this new VCF CLI to do this. So we can create a context for this cluster to be able to switch between that vSphere namespace where we were deploying the cluster itself, and then also the context of the cluster to deploy things inside of that. So if I list my clusters, I can see it's now there and it's running. And then I can go ahead and do some further configuration. Going back to the secret, now I have deployed a Kubernetes cluster, and I will be deploying a container on top of it that I want to be able to reach into the secret store. Now, everything we are doing in VCF is taking security into consideration, because obviously we're doing private cloud. Everything we deploy and use is using this paravirtualization model, where we never allow resources to directly reach into these important services. So we have to create some permission links to be able to connect to the secret store and retrieve that configuration. What I'm going to do here is 2 steps. First, I'm going to create a service account and a token for it on that vSphere namespace level, which has access to the secret store. And then we will do the second part on the Kubernetes cluster. OK, so now I've created my secret and a token for it. And now I'm going to create context for that Kubernetes cluster. So first, I'm going to register it. I'm going to get its kubeconfig. I'm just adding it to my existing file and create context for it. Provide an API token, which is something I would have created in my automation portal. And once I have my context created, I can then use it. So this is something I would create the first time I deploy the cluster, and then I'm able to very easily switch between the 2 contexts. So once I'm switched into the cluster, we can proceed with the other tasks. So if I get nodes, I can see I have my control plane and my node pool already. So the first thing I'm going to do, I'm going to create a namespace within my Kubernetes cluster. This is where I will deploy my application. And now I'm going to create that connection for service accounts to be able to reach to that secret store. We will not go through this configuration line by line, but I did want to show you how kind of the steps that you need to take to put this in place. This is fully documented in our documentation as well. So I'm going to apply that. And then I'm going to label my namespace to change the pod security policy to be able to deploy my containers under my pod. And if we look here, this is again something that we provide fully in the documentation, so you don't have to write this yourself. But this deployment of a vault injector is what is used to inject that secret into those containers. As I mentioned, the secret store is based on OpenBAU, and here we have the injector that will get deployed, and this will be responsible for reaching into the secret store, getting the secrets, and then injecting it into our deployments. So the only thing that you really need to focus on when you are deploying this, and again, we do provide the full config, is there is a value I want to highlight that you need to change, and this is the IP address of the secret store itself, so it knows where to reach. And the easiest way to get that, for example, if you have vSphere client open, if you go to secret store namespace, you will be able, under network and services, you can always grab the external IPs. So we can see it's .10, and then we can use that to define where it should be connecting to. And there's also a lot of other stuff that we have to create for this to work. Again, this is all configuration that is provided. So I'm just going to apply that. And all of those required resources will be created. And now we can start deploying the container as part of our application. So starting with the backend, because this is the important part to show with that injection of the secrets. As you see, it works on annotation base, and we have to provide annotations to basically tell it where to grab the secrets, but also then what to inject it into. So that's the configuration I'm highlighting here. And also, that's the connection to the MySQL VM we have previously deployed. So now I can just deploy that very quickly. That's all created. And to verify that that secret was injected correctly, I can go and have a look directly into that pod. And you will see that in that path that was defined, we will have this db.env file that has all of those details that we have added in the secret. So we can see that the injection is working correctly, as it should. And then the front end, again, that's just a very basic web front end. So we just go ahead and deploy that. It also has a service that will give us an external IP that we will then grab to access the application. So now that we have the IP, just take that, open it in our browser, and access the application. Again, this is very simple. I can go ahead and register a new user. This will be written in the MySQL database. To verify that that worked, I can log in with the user, and I can also write something new to the database. This is part of those tables we were creating in the initial configuration of MySQL. So we can verify that everything is working correctly, and as expected, the full application is deployed, and we can continue. So in here, what we have seen is how we can use multiple services in VCF to deploy an application. Because again, it's not about deploying single objects. It's all about how do we connect the dots and work with this together. The last part of this demo is an introduction of another service, because the whole idea of this platform is that it is extensible. You can introduce new services to really cater to your needs. If you want to do things in a different way, we want to support that as well. So what we have done in this first part of the demo, we've used the user interface to create all of our objects and deploy it. In reality, if you're deploying applications, you probably will not be creating every object in the user interface. The beauty of this, though, is that as you have seen, everything is defined natively as code. Everything is stored in a YAML manifest. So what I can do is I can grab those manifests, store them in a Git repo, and introduce GitOps to my platform. And to really unlock that, we have introduced Argo CD service into our platform that you can deploy and then go ahead and use. So in this section, what we will do is I will show you the full flow of how you introduce Argo CD service to a platform, and then use that to really maintain the desired state of the application. So that's going to be here. Now, what we will start with is the process of introducing new services. When we are working with deploying the services that were there, you saw in the user interface, we had that integration directly. You can just go to a tab to deploy a Kubernetes cluster or a virtual machine. But in here, we are introducing new capabilities to the platform, so it's something the cloud admins would be doing. That's why I will show you the flow of doing this in the vSphere client. So to add a new service, it's very simple. We have to upload a service definition file for the service. This is something you can go and grab from our portal. There are links in the UI to get you to the right space. And the way we implemented Argo CD service is in a true operator model. So what I'm doing here is, first I'm going to deploy an Argo CD operator. So I register it with vCenter, and then I go to Manage Service. And I'm going to select the supervisor where I want to deploy this to. I don't have to change any configuration. Just click Finish. And this is all done. So as a cloud admin, even if this is something that I wouldn't be using myself, I do not need to understand it. I do not need to know how to work with something like that. To allow my users on the platform to use these services, all I have to do is introduce the service. This is where my role as an admin ends. I've introduced the service. I will just wait for everything to get deployed. Argo CD operator being very simple, so we're just waiting for the controller manager to be up and running. So that's all I had to do. Download the file and install it. Now, we're going to go through the process of how do we now work with this further. So I've switched back to that vSphere namespace. And now, as a consumer, what I can do, I can check which versions are available for me. Because everything we are working on is based on this declarative API that we have integrated into VCF, you will see that the whole idea of that is Kubernetes-based and extended with all of these other resources that we are introducing. So I can use standard kubectl commands to describe those CRDs, those custom resource definitions. So now that we have Argo CD, if I explain that, I will be able to see that it's introduced to the platform. And if I want to check specific things, like which version is it, I can also go ahead and do that. So now I can go ahead and deploy an Argo CD instance. So as a user, I will have my own instance that I will use to deploy my applications. The minimal config is very simple. All I'm defining is a name and the version I want to deploy. And I will just wait for everything to be deployed. Now, there are two things that you need when you deploy your Argo CD instance at the beginning. The first is the external IP you will get to connect to it. And the second one is the default secret, which is the password that you will need to connect to the instance after the first deployment. So I've grabbed both of those. And then I can use Argo CD CLI, which is also something we distribute with the package when you go to download it, to log into my Argo CD instance. And the reason why I'm doing this is I want to update this password because I don't want to remember that default one. So I'm going to log in, use that password, and then change it to something I can remember. So every time I go to log in, I'm able to do that. So I've updated my password. And now what I will do here is I'm going to add my namespaces as the deployment target for Argo CD. So I've done that. It will go ahead and configure all of the necessary permissions that it needs. And now, just getting that IP, going to the user interface, we'll see our Argo CD instance. That's there. So I can log in with the password I have just changed. And I can go ahead and start using this. If you're not familiar with this, I will keep this very high level just to kind of show you the idea. But Argo CD is one of the most popular tools for continuous delivery coming from the CNCF ecosystem. So what we're going to do here is we're going to create an app within Argo CD, which will correspond with our 3-tier application that we have been deploying. And now we're going to open we have created a Git repo for this application and put all of those files there. Now, this has multiple waves. I will not go into the details, but basically how this works is I do have a parent application. This is the definition of the Argo CD application itself. So it's telling you things like, where's my source code, and where am I deploying this to? And then I do have my apps, my child apps. And for example, in here, you can see these are the manifests that we have created in the UI and then added here. So all you have to do is just whatever you have downloaded, you can just add to a repo and use that. So for example, this is the cluster. Now I can go ahead and create this. Again, I could use the UI or use that prepared YAML just to make this faster. Save that, and then just create this. And this will go ahead and basically take the desired state that is defined and code in my Git repo and match it to the platform. So we'll go ahead and make sure all of those components are synced and are there and configured. And in here, for example, if we look at our application, we can see it's deployed again. We can grab the service again, and then see that it's back up and running. But the idea about continuous delivery, obviously, it's not about the initial deployment. It's about continuous delivery. So now every time I want to make a change to this configuration, this deployment, I don't do it on the object itself. I define it in code. So just to show that as an example, if I go back to that Kubernetes cluster, and I've now decided that, you know what, I wanted to deploy 2 worker nodes for this configuration, again, keeping this very simple, I can change the number of replicas in my code, always add a commit message. It's a good way of doing it, so everyone knows what's happening. And then this will be synced. So if I will go and look into it, you can see all the resources. There's a lot when it comes to Kubernetes clusters. And the deployments, but if you look into machine deployments, you will be able to find that the desired state is already matched. So the number of replicas is already 2, and now it's deploying it. So in here, if we scroll, we can see that the second machine is being deployed next to the original one. So we'll wait for that to be ready. Back in vSphere client, we can see that the second node pool, the worker node, is being deployed. And after a while, we can see that's back at being healthy. And everything is synced as it should be. So this is really just to show you the principle of how we can take something that the platform gives you by default, like defining every single piece of every single resource in code, and how you can use this for maybe some other more advanced use cases, like if you use GitOps or would like to use GitOps, how to make it easier for you to do that on our platform. And the last section, because we do have a few more minutes left, what I would like to cover is, let me just quickly show you. Everything we have discussed here was really about this declarative API that we have in VCF. Now, in order to be able to use all of these services, this is something that you have to enable. And we will not go through the full process of this, but I do want to highlight what this is because it is really important to be aware of that, because all of this experience is reliant on that. And that declarative API is called vSphere Supervisor. We have also introduced new ways of enabling this to allow you to do this at scale. So you can now enable this functionality directly when you are creating your workload domains. So that's the flow I want to show you here, just so you know what to kind of look for when you are creating your workload domains. So I will just go ahead and create a new one. And right on the first page, you will see it. There's this toggle button for vSphere Supervisor, whether you want to enable it. If you want to use all of these cloud services, this is something this is reliant on, because that's what's providing you this experience. So you have to keep this option enabled. If you do decide to deselect it here, you can always go back to the vSphere client post-workload domain creation and run through the flow there. So you can still do it afterwards, but to make it easier, you can directly enable it here. All this will add, and again, I don't want to spend the whole time walking through these steps, because you've probably done this a million times if you are deploying workload domains. All of those other configuration options are not really related to Supervisor until we get to step 9. So you will see that in here, you will be just given the name, then defining some CIDRs, and in this flow, it's also using that integration with VPCs we have introduced in VCF 9. So you are just consuming whatever has been created. So it will be, if you do have one created with the default connectivity profile, it will just automatically select that for you. So really, just few options you have to define for the supervisor itself to get configured, and then continue with the deployment. The other thing, when you deploy this, you will notice that after it will finish this configuration, there will be a message that this also needs, for the current configuration, it does need edge cluster configuration. So it will just give you this information, and then you would go ahead and proceed with that configuration as well, as you would for your other environment. So again, won't run through everything in there, but I wanted to highlight especially that first section, because it's really important. If you do not enable Supervisor, you would not have access to all of these great. Ooh, no, not what I wanted. OK, so let's go back here. Right. So as you have seen, in VCF, we have really tried to provide this cloud experience, especially focusing on the cloud services that we are providing. And this is not just the runtime services. So again, it's not just about the VM. It's not just about the container or Kubernetes cluster. It's about the integration with everything else. So your infrastructure services for your load balancing or storage, but also all of these additional services that you can bring onto the platform to really extend the capabilities. And all of this is controlled with the single declarative API target from the consumer perspective, cloud experience, but also still within that governance that cloud admins have in place. So that was it from my side. Thank you very much. And if you have any questions, I'm happy to answer them now. Thank you.